Hey, what's up, guys? This is Akshay from AS Learning, and today we are back with another video in our data science interview series. And today we'll be discussing one of the most fundamental and the most basic questions of data science, that is, explain bias versus variance trade-off, or what is bias or what is variance. Bias, variance, and bias versus trade-off is one of the most basic and the most fundamental thing which any machine learning enthusiast or data scientist should know. So let's discuss. First of all, let's try to understand what is bias. Okay. So bias, it, let's go in a very informal way. Okay. So it's an erroneous term which gets introduced into your model when the model is in underfitting state. And variance is the erroneous term which gets introduced in model when the model is in overfitting state. Exactly. When your model is in the state of underfitting, at that time the errors or the erroneous state, we talk it in the way of bias. Bias is high and these things and all. And when the model is in the overfitting state, we talk that thing in terms of variance. Now let's try to understand this in a much more better way with the example. Okay. Now let's try to understand this graph. The model complexity is going from low to high. Okay. And we have our prediction error on the y-axis. The green line indicates my training data. Okay, my training data, and the red line is my test data, the performance of a model on the test data. Now as you can see, the prediction error on the training data is going down when my model complexity I've been increasing. Okay, and at a certain point, my prediction error on the test data is increasing after a certain point. Okay, the on the test data also the prediction error was going down. Okay, the test data is the red line and the training data is the green line. Okay, and after a certain threshold or a point that the prediction error went up. Okay, that point is a point where, as per the data, your model is having the best parameters, or that is the point where we have to deal with your bias and variances. So that point is called the trade-off point between your bias and variance. All the section of the area on the left side of that point, it comes in the underfitting zone, and all the section which comes on the right hand side, it comes in the overfitting zone. Now, what happens in the underfitting zone? In the underfitting zone, the bias is high. Bias is high and the variance is low. And the overfitting section, the variance is high and the bias is low. Okay, and a typical point is called as bias versus variance trade-off. Okay, and that is the ultimate goal of any data scientist, to find those parameters for a model. Okay, that typical point is called as bias versus variance. Any ideal model, any ideal machine learning model should have a low bias and a low variance. Okay, let's try to understand this with another example. This is a very popular example. You must have seen this figure a lot many number of times. Okay, any ideal model should have low bias and low variance, no bias errors and no variance errors. Simple as that. Okay, but that is not the ideal case. In real world scenario, in real data, you can never have the case which is seen in the first circle, that is low bias and low variance. It is an ideal state. Okay, and because of this we have to figure out a trade-off, and that trade-off is called as bias versus variance trade-off. Okay, now let's try to understand this particular circular graph. Okay, now what is happening is, your variance is high when the data is spread out. Okay, so in the high variance section, you can see that whenever the data is spread out, you have high variance, and whenever the data is close, the variance is less. And in bias, what is happening is, whenever the predictions are close to the actual result, that is the red bullseye circle, at that point the bias is low. And when the predictions are away from the bullseye circle, the bias is high. Just try to correlate this thing with underfitting and overfitting. When the predictions are close to the bullseye, that is close to the actual points, your underfitting is going away, right? That's why the bias is also going away. You have low biases. Your model is reaching at optimum level. And whenever this data are spread out, you have high variance. Okay. So, and with high variance, high variance comes in picture when a model is trying to overfit. Okay. When your model is in a very complex state, when the model complexity increases, overfitting increases and the variance increases. When the model is simple, your model is in the underfitting state, the and in that state the bias is high and the variance is low.